Hello students, my name is Dhiren Singh and today we will discuss about the chapter solution. Most important chapter solution. It is important for both neet. It is important for both neet and ZEE. Okay. Today we will discuss. First of all, we will discuss concept and then we will discuss previous year questions of NEET and JEE Mains. So, let us start. First of all, what is the solution? So, solution, it is the homogeneous mixture of, homogeneous mixture of two or more than two components which is non-reactive, okay, which is non-reactive, and the properties of the solution, or you can say that properties of the mixture will same throughout the solution, okay. Means if we want to make a solution, then we take, like this is the example, we take water and add some amount of sugar molecule, okay, some amount of sugar molecule. This is water and these are the sugar molecules. So this is a mixture. This is an example of mixture. Okay. So here sugar and water both will form a solution, but they do not react with each other. In this case, water and sugar. In this case, water is act as solvent. Water is act as solvent, and sugar is act as solute. Okay. So overall conclusion is that solution is equal to mixture of solvent plus solute. Clear? Now, what is the solvent? Okay. So first of all, it present in larger amount in solution. And second one is that it provides medium to solute. Okay. Now solute. So solute, it present in smaller amount. It present in smaller amount and amount of solute in solvent and amount of solute in solvent represented by concentration. Okay, represented by concentration. So now it is clear what is solvent and what is solute. So next thing is that next is next we will discuss the types of solution. Types of solution. So solution may be binary and ternary and then quaternary. Okay, basically this is important. Only binary solution is important. Binary solution means solution having one solvent plus one solute. Okay, binary means two. Okay, so one is solvent and one is solute. This is called binary solution. And in case of ternary solution, one solvent plus two solute. And in case of quaternary solution, one solvent plus three solute. Okay, in all the cases binary, ternary and quaternary solution, solvent always be one. Okay, now next types of solution are based on physical state. It is based on physical state. So you know the types of solution based on physical state. Solution may be liquid solution. Okay, then solid solution, and third one is gaseous solution. Okay, now liquid solution is also divided into three types: liquid solution, liquid solid solution, and liquid gas solution. This is also divided into three parts, and this is also divided into three parts. Okay, this will be solid, liquid, solid solution, and solid gas solution. Same will be gaseous solution. These are the types of solution on the basis of number of solute and solvent, and on the basis of physical state. Okay, now we will discuss the concentration term which is most important. And concentration term, we will divide the concentration term into two parts. First is mass dependent concentration term. Mass dependent concentration term, and other is volume related, or you can say that volume dependent concentration. Okay, mass related concentration term generally are mass by mass percentage, or you can say weight percentage. Mass by mass percentage or weight percentage. Next is molality. 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 It is also mass dependent. Next is mole fraction. Mole fraction. Mole fraction. And parts per million. Parts per million means ppm. Okay, these are the concentration term which is dependent, mass dependent. Okay, now next is volume related concentration term. Volume related concentration term are volume by volume percentage. Volume by volume percentage. Next is mass by volume percentage. Mass by volume percentage. Mass by volume percentage. Third is molarity. Molarity. Next is normality. 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 Okay, and other will be formality. Okay, formality. These are the mass related concentration term. Mass related concentration term. And now you know that mass related concentration term means these. Sorry, volume related concentration term. First of all, volume related. Volume related concentration term means these all concentration term. These are also temperature dependent. These are temperature dependent. And mass dependent concentration term. Mass dependent concentration term. These all are temperature independent. Temperature independent. Okay, these are temperature independent concentration term. Clear? So one question is comes in NEET 2017 from only this topic, from this classification. Okay, so what is the question? Question was which of the following is dependent on temperature? Question was which of the following is dependent on temperature? Following is dependent on temperature. Okay, option first was molarity. Second option was mole fraction. And third option was weight percentage. And fourth option was molality. Okay, this was the question in NEET 2017. So option was molarity. Molarity is the temperature dependent concentration term. Okay, clear? So next is we will discuss one by one. First is mass by mass percentage. You know about mass by mass percentage. Mass by mass percentage, or you can say weight percentage. So formula for mass by mass percentage or weight percentage is equal to weight percentage is equal to weight or mass of solute divided by mass of mass of solution, mass of solution into 100. This is the formula, for mass by mass percentage, and it is a unitless, it is unitless. Okay, next will mass by volume percentage, mass by volume percentage. Okay, what is the means of mass by volume percentage? Formula for mass by volume percentage will be equal to mass of solute divided by volume of solution into 100. This will be the formula for mass by volume percentage. Okay, this will be the formula for mass by volume percentage. Okay, for example, if a statement is given like 10 gram of sugar dissolved in 90 gram of water. Okay, so this statement is for mass by mass percentage. Mass of solute means 10 gram sugar. Okay, its mass is given. Then mass of solution will be 10 gram solute plus 90 gram solution. So mass of solution will be 100 gram. Okay, same will be for mass by volume percentage. So both are clear. Mass by mass percentage, mass by volume percentage. Okay, next will be volume by volume percentage. In case of volume by volume percentage, the formula for volume by volume percentage will be equal to volume of solute divided by volume of solution into 100. Okay, it will be also unitless. Clear? Everyone knows about mass by mass percentage, mass by volume percentage, and volume by volume percentage. Next is molarity. This is important. Molarity. It is represented by capital M. So, what is the molarity? Molarity is the number of moles of solute. Divided by volume of solution in a liter. Okay, this is called molarity. Okay, unit of molarity will be, unit is equal to number of moles. It have unit mole and solution in liter. Then unit will be mole per liter. You can also write it like mole dot liter inverse. Okay, so this formula, you can write this formula in shortest term. Then will be M means molarity is equal to number of moles divided by volume of solution in liter. Okay, volume of solution in liter, because number of moles denoted by small m. Number of moles denoted by small m. Next thing, if we take solution in ml, then formula will be number of moles of solute, number of moles of solute divided by volume of solution in ml, then multiplied by 1000. Okay, this will be the formula of molarity. Clear? Molarity in terms of diffusion and mixing. Molarity in terms of diffusion and mixing. Molarity in terms of diffusion and mixing. Molarity. Okay. First formula is m is equal to n by volume in liter. Okay, this is the formula. And molarity in term of dilution. In case of dilution, formula of molarity will be m1v1 is equal to m2v2. m1v1 is equal to m2v2. This formula will use in case of dilution. Okay, but in case of mixing, second thing is that in case of mixing, mixing means when we mix two or more than two solution, then formula will be m1v1 plus m2v2 will be equal to m3v3. This will be the formula in case of mixing. Okay, so question based on molarity. Question is 2 moles HCl, 2 mole of HCl dissolve in 2 mole of HCl dissolve in water to make 4 liter solution. To make 4 liter solution. Then molarity of solution is option A is 1 molar, option B is 0.5 molar, option C is 0.25 molar, and option D is 0.75 molar. Then you know the formula of molarity. Molarity is equal to number of moles divided by volume of solution in liter. Okay, so number of moles directly given 2 moles of HCl, so 2 divided by volume of solution make 4 liter. So molarity will be 2 divided by 4 will be equal to 1 by 2. So it can also write as 0.5 molar. So option B will be correct option. Clear? Now next is molality. Next is molality. Next is molality. In case of molality, it is represented by small m. It is represented by small m, and formula for molality small m is equal to number of moles of solute divided by amount of solvent, or you can say mass of solvent in kg. This will be the formula for molality, and unit will be number of moles, so it has mole per kg. Okay, so mole per kg. You can also write it mole dot kg inverse. Okay, this is the unit of molality. So if we take solvent in gram, so formula will be molarity is equal to number of moles of solute divided by mass of solvent in gram, then multiplied by 1000. Okay, this will be the formula. Clear? Now question based on this topic is question was in 1 molar solution, that contains 0.5 mole of 0.5 moles of solute, 5 moles of a solute. There is option A 500 ml solvent present. Option B 500 gram solvent present. Option C is 100 ml solvent present, and option D was 1000 gram solvent present. Okay, so these are the options. This is the question has been asked in NEET 2022. Okay, so given 1 molar means 1 m. 1 molar solution contains 0.5 moles of solute. 1 molar solution contains 0.5 moles of solute. Okay, so 1 molar solution means 1 mole of, if solvent is not given, then 1 mole of solute of 0.5 mole. 1 mole of solute dissolve in sorry okay 1 m. Answer is 1 m. Means molality is given and ask the amount of solute. So you know the direct formula of molality. Molality is equal to number of moles of solute. Okay, solute divided by solvent in kg. Okay, so here option not given is in kg, option given is ml and gram. So we will convert this formula in gram. So mass molarity will be number of moles divided by solvent in gram multiplied by 1000. So molarity is given, it gives 1 molal. So molarity is 1 is equal to number of moles it is also given 0.5 mole, it is also given 0.5 into 1000 divided by solvent in gram. This is not given, solvent in gram. Okay, so we calculate solvent in gram, multiply. So solvent comes here and 1 comes here. So solvent in gram will be equal to 0.5 into 1000 divided by 1. So it will be equal to 5.5 into 1000 will be 500 and in gram. So option B will be correct. Option B will be correct option. Option B will be correct option. Clear? Option B will be correct option. Option B will be correct option. Okay, any doubt? So next is relation between molarity and molality. Relation between molality and molarity. So next formula is relation between molarity and molality. Clear? So relation between molality and molarity. So M for molality. Molality is equal to 1000 into M and divided by M into MB, M into MB minus 1000 into B. 1000 into B. This is the relation between molarity and molality, where this M will be molality. This M will be molality and this M will be molarity. This also be molarity and MB is the mass of solute. MB is the mass of solute and D, this is the density. Okay, this is important formula, relation between molarity and molality. Clear? Molarity and molality. Now next is normality. Next will be normality. It is represented by capital N. It is represented by capital N. Okay. So normality, it is equal to number of, normality means N is equal to number of gram equivalent of solute, number of gram equivalent of solute, number of gram equivalent of solute divided by volume of solution in liter, divided by volume of solution in liter, okay. This will be the formula for normality. Now this is the question, how we calculate number of gram equivalent of solute. What is the number of gram equivalent of solute? Then formula for number of gram equivalent of solute, number of gram equivalent of solute, it is equal to gram equivalent mass, or sorry, given mass divided by equivalent mass. It is equal to given mass divided by equivalent mass. Okay. Number of gram equivalent will calculated by this formula. Number of gram equivalent of solute is equal to given mass divided by equivalent mass. So given mass, it will be given in question. Then now question is that what will be the equivalent mass? So formula for calculating equivalent mass, it is equal to molecular mass divided by n factor. It is equal to molecular mass divided by n factor. Okay. Now next question, what is the n factor? So n factor for acid and base, clear? Now we calculate n factor for acid and base. N factor, okay, for acid, okay, for acid, if we calculate n factor for acid, like example, we take HCl. If we dissociate HCl, then it will dissociate into H positive. It gives H positive and Cl negative. Okay. And if we take H2SO4, it gives 2 H positive ions plus SO4, 2 negative ions. So here HCl gives 1 H positive and H2SO4 gives 2 H positive. So here n factor, value of n factor will be 1, and for H2SO4 n factor will be 2. Okay. And this is called basicity. Okay. Means acid can give H plus ion. How many H plus ion can give? That is called basicity of that particular acid. So basicity of HCl is 1, or you can say n factor for HCl is 1. Okay. Same for basicity for H2SO4 is 2, or you can say that You can say that n factor for HCl H2SO4 is 2. Okay. Same. These are the normal example. These are the normal example. If we take some important example, if we take some important example like H3PO2, H3PO3, H3PO4. Then what will be the acidity? What will be the basicity for these particular acid? What will be the basicity for these particular acid? These are very important. Example. If you dissociate into H3 plus PO2 3 minus, like H3H plus and 3H plus, then this is not correct option. This is incorrect. So what will be the correct option? What will be the correct option for these type of example? So let us H3PO3. First of all, it have one phosphorus, two oxygen, and all have one phosphorus. So first of all form one phosphorus, and one phosphorus will attach with a double bonded oxygen. Now if we draw this structure H3PO3, then phosphorus have two oxygen, and one oxygen will form double bond, and remaining one oxygen will form OH bond. Okay. Now two remaining hydrogen will form directly attached with phosphorus. Okay. If we draw this structure H3PO3, then same trick apply. One phosphorus will directly attach with oxygen, and remaining oxygen is 2. So 2 remaining will form single bond with OH, and then if hydrogen is remains, then directly attach with phosphorus. Now for H3PO4 phosphorus gives double bond O, then 3 oxygen remains, then it will form 3 OH bond. So OH bond. So OH, this group will give H plus ion. OH group will give H plus ion. These cannot give H plus. These cannot be H plus. Okay. So in case of H3PO3, one OH group is present. So it give only one H positive plus H2PO2 one negative. Okay. In case of H3PO3, it have two OH group. So it will give two H positive ions. And in case of H3PO4, it have three OH groups. So it can give 3H positive plus PO4 3 negative. So basicity for this will be 1, and basicity for this will be 2, and basicity for this will be 3. Okay, clear? This is the basicity or n factor for acid. Now next is n factor for base. N factor for base it is called acidity. N factor for base, it is called acidity. So if we take example like NaOH, KOH, NaOH. Okay. So after the dissociation, it gives K positive plus OH negative, and NaOH gives Na positive plus OH negative, So you know that base gives OH, OH negative ions. Base gives OH negative ions. So here basicity is equal to means n factor for base will be equal to OH negative ions. OH negative ions. KOH gives one OH. So here n factor. So here n factor will be 1, and in case of NaOH n factor will also be 1. N factor will also be 1. Okay. Like if we take CaOH whole twice, it will gives Ca 2 positive ions plus 2 OH negative ions. So n factor will be 2. Okay. If we take MgOH whole twice, then it gives OH 2 OH minus and Mg2 positive. Okay. In case of MgOH whole twice, it gives Mg2 positive plus 2 OH negative. Mg2 positive plus 2 OH negative. Okay. So it gives n factor is equal to 2. Same for AlOH whole thrice. It gives Al3 positive plus 3 OH negative. N factor will be 3 for this concept. Okay. Clear? So next is for n factor in case of salts. It is important. N factor for salts. Okay, n factor for salt. Like if we take salt NaCl, it will dissociate and give Na positive ion plus Cl negative ion. Na positive ion and Cl negative ion. Okay. So n factor here n factor will be 1. N factor will be 1. How n factor will be 1? So in case of salt, n factor will be equal to total number of in case of salt, n factor will be equal to total number of charge on cation or you can say that charge on total number of charge on anion. Okay, anyone, it will be equal to total number of charge on cation or it will be equal to total number of charge on anion. So here sodium have one positive charge, so n factor will be 1, or you can say chlorine have one negative charge, so n factor will be 1. Clear? So if we take example like Na2SO4, so n factor will be, it gives Na2SO4, it gives Na2 positive, Na2Na positive plus SO4 2 negative. So SO4 have 2 negative charge and 1 sodium have 1 positive, then 2 sodium will have 2 negative. So n factor will be 2. Okay. Same if we take example Al2SO4 whole thrice, then it will dissociate and give 2Al3 positive plus 3SO4 2 negative. So total charge 2 multiply by 3 will be 2 multiply 3 will be 6. So n factor for this compound will be 6. Okay, this is the n factor for salt, n factor for salt. Now if number of moles given in question, if number of moles given in question then number of gram equivalent will be formula for number of gram equivalent will be n into n factor, where n is the number of moles of solute, okay, number of moles of solute. Clear? And this is about the sum concentration term. So थैंक यू, मिलते हैं नेक्स्ट वीडियो में. ओके, बाय बाय.